now we have come to 1.4.2, solve indefinite integrals by substitution method. Okay, so basically in this type of case, we can either integrate straight away by changing the values of the boundaries a and b, and we can also do that without changing the boundaries. So normally it would be safer not to change the boundaries, so that in the end you can use the boundaries with respect to x after we get the integral with respect to u. Okay, but it is also fine to change the boundaries with respect to u straight away, so that in the end you don't have to revert back to x. However, in this example, I'm going to show the solution without changing the boundaries. Okay, so now in this case we have 3x squared and x cubed plus 1. So for substitution method, we choose the one with the more complex form or the higher power of x to be let equal to u. Okay, so let u equal to x cubed plus 1. So du dx is equal to 3x squared, and then we can see that du is equal to 3x squared dx. So from the question we can see that 3x squared and dx can be replaced with du. Okay, and then we can also see that x cubed plus 1 can be replaced with u. So we're not changing the boundaries, therefore we don't have to make any calculation to change the boundaries of -1 to 1. Okay, now we can do the integral of 3x squared times the square root of x cubed plus 1 dx is equal to u du. Okay, and don't forget that we have u to the power of 1 over 2, and then integrate that with respect to u. We get u to the power of 3 over 2 over 3 over 2 plus c, and then rearrange that. We get 2 over 3 u to the power of 3 over 2 plus c, and that now we want to revert back to x. So rewrite the integral, the original integral, which is the integration of 3x squared times the square root of x cubed plus 1 dx from -1 to 1. So we get 2 over 3, then times u, which is x to the power of 3 plus 1 to the power of 3 over 2, and then we put the boundaries from -1 up to 1. Okay, and then substitute the boundaries. We get 2 over 3 times 1 to the power of 3 plus 1 to the power of 3 over 2, and then substitute -1. So 2 over 3 times -1 cubed plus 1 to the power of 3 over 2. So for the first one we get 2 over 3 times 2 to the power of 3 over 2, and for the second one we get 0, and then finally we get 2 to the power of 5 over 2 over 3, which is equal to the square root of 32 over 3 and finally equals to 4 square root of 2 over 3. Now let's try some trigonometric integrals. Okay, from this we have the integration from 0 to pi of x cos x squared dx. Alright, so let u equal to x squared. So du dx is equal to 2x, and as we can see from the question, we want to replace x dx. So x dx is equal to 1 over 2 du, and then cos x squared becomes cos u, okay, and then rewrite the question without the boundaries. So we have the integration of x cos x squared dx is equal to the integration of 1 over 2 times the integration of cos u du, okay, and then integrating cos u, we get sine u, then plus c, the constant. So now we're gonna substitute u back with x. So rewrite the original integral from 0 to pi. X cos x squared dx is equal to 1 over 2 sine x squared, and then we put the boundaries. So we have 1 over 2 sine pi squared minus 1 over 2 sine 0. So finally we get 0.215. Sorry, negative 0.215.